This is lab partner number 1. In this video, she will demonstrate how to calculate the volume of a solution by difference. This is a pipette. It is a precise measuring device used for finding the volume of a liquid. Prior to using the pipette, it's important to prime it. To do that, you add water to the pipette and let it out to cleanse it, and repeat this process 3 times. To correctly take up a solution, place the pipette in the beaker containing the solution. Squeeze the pipette bulb and gently place it on top of the pipette. Release the bulb to uptake the desired amount of solution, and to stop it, quickly take the bulb off the pipette and place your thumb on the top of the pipette to contain your amount of solution. To properly read the volume in the pipette, you read from the bottom of the meniscus. The meniscus is a crescent shape in the solution caused by surface tension, which attracts the solution to itself and the sides of the pipette. You must hold the pipette at eye level to read the volume. The volume of this solution is 2.9 milliliters, which is what you record. To find the volume by difference, you must take another volume of the solution. Release some of the solution into another beaker by removing your thumb from the top of the pipette until you have your desired new volume. Once again, raise the pipette to eye level and read from the bottom of the meniscus. The new volume of the solution is 5.7 milliliters. Once you record the volume, you can release the remaining solution into a beaker. To calculate the volume of the solution by difference, you subtract the initial volume from the final volume. So this volume will be equal to 5.7 milliliters minus 2.9 milliliters, which is equal to 2.8 milliliters. Here is lab partner number 2. She will also be demonstrating how to calculate the volume of a solution by difference using this pipette, which was already primed. Remember to squeeze the bulb before placing it on the pipette. Once you have your desired volume, raise the pipette, locate the bottom of the meniscus, and read the volume from there. The volume of this solution is 7.1 milliliters. After releasing some of the solution, the final volume is 8.3 milliliters. Now you can do the calculations. Remember, the volume is equivalent to final volume minus the initial volume. After typing this into the calculator, we see that the volume of the solution is 1.2 milliliters. Last but not least is lab partner number 3 to demonstrate the calculation. With this prime pipette, you will receive an initial volume of a solution. You have to be quick when you remove the bulb and replace it with your thumb so you don't lose some of your volume. Look closely at the bottom of the meniscus of the solution to read the volume. The initial volume is 4.9 milliliters. Make sure you are correctly labeling and recording your data in your lab notebook. The final volume is 6.0 milliliters. Now you're ready to complete the calculations, which you can do by subtracting 4.9 from 6.0, which makes the volume of this solution 1.1 milliliters. Now lab partner number 1 will perform calculating the mass by difference of a solution. Start by tearing out the balance so it's completely at zero. Open the side door on the balance and place the beaker inside. Make sure to close the side door to prevent getting inaccurate data because of air currents. Wait for the scale to stabilize before you record the value. It's important to record the mass with significant figures so your value is as accurate as possible. The mass of the beaker is 30.4219 grams, which is recorded in the lab notebook. Then remove the beaker from the balance and add the desired amount of solution. Place the beaker with the solution back on the scale and close the door. Once the scale is stabilized, record the mass, which for this happens to end up being 45.9058 grams. To calculate the mass of the solution, simply subtract the mass of the beaker from the mass of the beaker with the solution. It's important when using big numbers to check your work with the calculator. After completing these calculations, we find that the mass of the solution is 15.4839 grams. Lab partner number 2 will show the same calculation. You must tare the balance to get accurate values. The mass of this beaker is 30.4269 grams. Remove the beaker from the scale in case you spill some of the solution and won't be on the scale and affect your results. The final mass of the beaker containing the solution is 46.3196 grams. Using a calculator to complete the calculations, we find that the mass of the solution is 15.8927 grams. And now lab partner number 3 will perform the calculation. Once the scale has been tared, place the empty beaker on it. With all doors closed and the scale stabilized, record the mass. This beaker's mass is 30.4217 grams. Remove the beaker from inside the balance and carefully pour your desired amount of solution into the beaker and place it back inside the balance. Wait for the accurate reading to record the new mass. The mass of the beaker with the solution is 49.5032 grams. Using the same equation as before and a calculator, we find the mass of the solution to be 19.0815 grams.